In this video, I'm going to show you how to match standard A1.3.B. So let me go over that real quick, what that means. So this problem wants you to represent a function with symbolic expression as a graph in a table and using words, and to make connections among these representations. It's obviously going to be difficult for me to do every single possible way to make this happen, because there's a lot of things that are happening. You can do it as a symbolic expression, as a graph, in a table, and using words. But the important part, the thing you need to focus on, is to make connections among these representations. So the whole point of this standard is not to produce a single equation that you're going to solve, or a graph, or a table, but rather to go between different ways of representing an expression and show how one of those translates into the other. The important part is the connection piece, not the final equation or graph. So I'm going to give you an example and then show you how one of the connections works. So let's start again with our same, I need to change my camera. Let's start again with the same general sequence that we used before: -10, -15, -20, -25, so on and so forth. If I was going to turn this into an expression, I would say that A sub n equals A1 plus D times parentheses n minus 1. And that is my general form of my equation. And if I wanted the explicit form for this expression, I would say A sub n equals -10 plus -5 times the quantity n minus 1. Let's do it in black. Minus 1. So there would be my expression. A sub n is equal to -10 plus -5 times n minus 1. And the important part for A1.3.B is to make the connections for where you got these numbers from to the original sequence of numbers. So this -5, it comes from the fact that in every single term is 5 less than the one before it. So this difference is my common difference. And A1.3.B is just trying to see if you can show how one part of your equation, in this case the -5, comes from this expression. And the arrow is what they're looking for. They're looking for that connection, that either arrow or descriptor that says, look, this number, -5, actually comes from my expression, or from my sequence up here. And those two things are exactly the same idea. So they're looking to see that you can translate your equation, which is one way of representing it, into another. Now here I was putting a kind of a box around my -10 and then drawing an arrow up to here, because this is my first term. And so in my problem, this -10 in my sequence becomes the -10 in my equation that I add at the very beginning. That's what A sub 1 is. So that connection, that arrow that draws your mind from this equation to that part of my sequence, is exactly what you need to be doing for A1.3.B. And n in this case is my general term number. So if my question said find the 13th term, then this 13 would go in and replace my n. So I'm going to write this new problem. So I'm going to do this problem down below. So that would look like this. A sub 13 is equal to negative 10 plus negative 5 times, for this problem, 13 minus 1. So then I just have a simple problem of solving all the different math. So this becomes 12, and that's still multiplied times negative 5. And then everything else is exactly the same. I'm not going to write this a sub 13 because it's just assumed since it's not changing, it's just going to remain the same. So negative 5 times positive 12 becomes negative 60. It's correct. Minus 10, 60. So that's these two get multiplied together to become that. I should draw little arrows that show the negative 13 minus 1 becomes a 12. And then the negative 5 times the negative 12, or times the positive 12 gives you negative 60. And then these two together, when you multiply them together, give you negative 70. And there is my answer. So a sub 13 in this question is negative 70. And if I was asked to explain my process and explain why everything worked the way that it did, I would need to draw the arrows like I had done before, and then also include arrows that show how that 13th term becomes the n in my equation. So the really important part is you're able to show how all the different pieces connect. Now, I'm going to turn this into a graph and show you the last step. So I'm going to have to kind of sketch this off to the side because I'm running out of room here. If I was to use this exact same process to kind of make a graph, I would start here, put my first term, second, third, fourth, fifth, sixth. We'll just go up to 6. And I'm going to have to start here, probably make the graph of my axis. This is a little bit ugly, so you have to forgive me on this, because I'm going to start at 0 here and then put negative 10, negative 20, negative 30, negative 40, negative 50. So my first term would actually be right here, my first dot. I'll put it in blue just to kind of re-emphasize everything. So there's my first dot for my first term, and then the next one is going to be right here, right here, and the third one is going to be right there, the fourth one's going to be right there, the fifth one's going to be right there, and it's going to continue on in this pattern. Kind of see the general line the way that it goes. So if I had to make a connection between this equation and this graph, I would say, look, this minus 10, that was my first term, shows up here in my graph like this. And then the common difference, the fact that every time you drop 5 when you go over 1, so my slope from this line is going to be negative 5 over 1, that this shows up right here on my graph as my slope. So all of those arrows and the connections, how it starts off as a difference here of negative 5, and here it's the variable d in my equation, which is multiplied times a parentheses, and over here in my graph it's the slope. That is what A1.3.B is. That's the guts of it.